Well, I'm here today to talk to you about the mysteries of sunspots. And right now they're a hot topic of research. There are a number of spacecraft that have been launched specifically to study the sun and the wavelengths of radiation that our eyes can't detect that are now orbiting the sun and turning back data. Our study of sunspots actually goes back several hundred years, as I'll cover in just a minute. But imagine, if you want to know how it affects you, imagine trying to answer your cell phone or tuning your favorite radio station, and all you get is an earful of static, or the signal cuts in and out. And imagine your power blacking out because of an overload to the electrical system. Your satellite's not working, so your GPS doesn't work. These are all things that happen when the number of sunspots is high and the solar output increases. Sunburns and melanoma, as Teresa just covered, they're one cause of higher solar output, and Idaho was ranked as a really high state. I don't know if it was the highest, but it was really high for melanoma deaths in the country. And it causes blackouts, electrical surges, interference, and it also can change our climate, though the extent to which is still uncertain. And since we all have skin and use electricity, this is a pretty relevant topic. I'm a long-time astronomy buff. I've always had a telescope since I was a little kid, and I have a friend who's a nuclear physicist who's always answered all my questions that I have, which are numerous. And I've been a long-time listener to shortwave radio, which is because the signal is reflected around the Earth off the ionosphere is very susceptible to changes in solar radiation absorbed in the upper atmosphere. It can basically make or break your radio reception. The sunspot activity has been linked to global temperature change for the last 100 years or so. We've had an idea that it might, but it's still not proven and nobody knows for sure. So first I'd like to define some characteristics of sunspots along with the history of the data collection on them. And then I want to relate sunspots to our climate, and then we'll look at where we are today with our solar cycle. So as many of you probably know, sunspots appear as dark spots on the sun, and they're dark because they're a cooler region of the solar atmosphere. But the surrounding areas around the sunspots actually heat up when the sunspots themselves cool off, and the degree that they heat up is actually more than the sunspots cool off, which results in an overall output of the sun. The sun actually produces a lot of X-rays and ultraviolet radiation that our eyes can't detect, and this is what we know actually increases in output during sunspots, but they do not increase from the sunspots themselves or from other seemingly unrelated areas of the sun. And another characteristic is that sunspots generally form one in the north hemisphere and one in the south hemisphere in pairs. Not always, but generally. I have a chart that will show you that in just a moment. According to my friend Dr. Currier in 2009, the sunspot activity increases the X-ray and ultraviolet radiation significantly will increase in areas unrelated to the sunspots, though some people in recent years have tried to show they come from sunspots. It appears to have just been a coincidence in the pictures that they chose to show. As early as 20 to 30 BC, the Chinese began noticing sunspots and actually made the first recordings of known sunspots that they could see with the naked eye, which are generally limited to very large ones, or when smaller groups grouped together into a big one. It wasn't until 1610 that Galileo, with his first telescope, many of you probably know he invented the telescope, he began to make counts on a daily basis with his telescope, and he could see many more. But unfortunately, in 1632, he was arrested and put in jail because his views didn't agree with that of the church. Luckily, others followed in suit, and their data, although incomplete by today's standards, has been reinforced by many other experiments. From 1643 to 1715, there were very few sunspots counted. This period is referred to as the Maunder Minimum, and it also coincides with the Little Ice Age that occurred at the same time, which are average temperatures cooled, and a lot of rivers and harbors froze that don't normally freeze. Many European paintings done, people ice skating on certain rivers and stuff that no one's ever seen ice on in our lifetimes. And that's the main evidence, that long period of linking it to our environment, because it's the only time it's ever happened during our 400 years of counting sunspots. It's pretty inconclusive, really. We do know that the sunspot activity, again, it lowers the output of the sun when there is no sunspots. We just don't understand why. Our last sunspot peak was in the year 2000, and they promptly predicted, since sunspots always happen on a 11-year cycle, the 11-year cycle, it peaks every 11 years, so they thought by 2011 we would have another cycle. And here you can see peaks every 11 years, and the top graph represents the northern hemisphere and the southern hemisphere, with sunspots occurring in pairs. And this graph shows the Maunder Minimum, the number of sunspots that coincides with the Little Ice Age, and how dramatic a change it is from sunspots today. And I guess I'm done.